Well, I thought that was going to be the last video, but I forgot to plug my computer in, and so it died. So you get one more video, and I think it ends up being Botany video 20. But anyway, sorry. Sorry about that. That's okay. It's not the end of the world. So here we were. I was about to tell you about endosperm, and it's triploid tissue naturally occurring. If you think about a peanut, you break a peanut in half. You got two sides like this, and one of the sides, let's do it in a different color. One of the sides is the embryo. Now, the embryo came from the zygote. The embryo is 2N, it's diploid tissue. But what about the rest of this stuff? Well, everything else is the endosperm. It's the germ. It's sometimes called the germ, like you think about wheat germ. Well, when they make wheat germ, they mechanically separate the endosperm from the embryo. Okay. So, most of a seed that you're eating is endosperm. It's triploid tissue. Okay. So, that is pretty much it for the life cycle. That double fertilization being the interesting thing that happens. And so one of the things I would like to do now is think about some differences between gymnosperms and angiosperms in terms of life cycle. And then at that point, we'll talk about angiosperms and what we consider to be more primitive angiosperms versus more advanced. And then we'll be wrapping it up, y'all. Okay. So what about it? What about some differences between gymnosperm versus angiosperm? They're both seed plants, right? Well, one of the obvious differences is the cone and the flower, if you're thinking about life cycle differences, right? We often think of the gymnosperm as being the tortoise and the angiosperm as being the hare. Remember the parable of the tortoise and the hare? The tortoise is slow and steady, wins the race, right? So when you think about conifers, for example, they're very slow to reach reproductive maturity. And then cones, it takes 3 years for a cone to make seeds, 3 full seasons or years. So you're talking about, we think about years to seed production. Well, in a gymnosperm, you got to figure about 10 plus 3 is about 13 years before you're going to see a seed come out of a gymnosperm. Angiosperms, you don't measure them in years. You can actually measure them in days. The fastest angiosperm is 28 days from seed to seed. That's the record, and it's a little plant called bitter cress. You've seen it growing in the late winter. It flowers and fruits really very quickly. So, there's this amount of time that it takes. And then the other big one is double fertilization. Right? We don't see that in the gymnosperm. So that's another difference. So that kind of gives you an idea, of how these two groups of organisms are different in terms, specifically talking about their life cycles. Now, if we think about the angiosperms specifically, and we think about primitive to advanced in terms of evolution, in other words, what are considered more evolutionary primitive and more evolutionary advanced traits within the flowering plants? Well, when you think about, first of all, what this term means, primitive and advanced in terms of evolution. You can think of it as primitive as being less highly evolved and advanced as being more highly evolved. And in terms of plant families, we might think of it like that. The most primitive plant family is believed to be the Magnolia family. The Magnoliaceae is believed to be really one of the first groups of flowering plants. The most advanced flowering plant is believed to be, or flowering plant family is believed to be the orchid family. We're going to see some incredible specializations of orchids. So many flower parts and large seeds are both considered more primitive traits. And so many flower parts, many stamens, many pistils, many petals, okay, and then large seeds. In the orchid family, we see very few highly specialized flower parts and tiny seeds. The seeds of orchids are literally like dust. You can just even barely see them, okay? So there's that. Wind pollinated. Or non-specific vectors. By non-specific, we mean, lots of different things will visit the flowers, lots of different kinds of insects, or they use the wind for pollination. Wind would be considered more primitive. Just if you ever have the opportunity, observe a tulip poplar flower on a tree. Tulip poplar is a very common tree here. If you can get to where you can see one, if it's low down, just watch it for 5 minutes during the spring and see how many different kinds of insects will visit that one flower. It produces huge amounts of nectar. And that's in the Magnolia family, so that gives you an idea. Here we have a single vector pollinator. And we're going to put mimicry here, and we'll see what that means. And we'll say and or mimicry. What we mean here is that there's one single species of insect or maybe animal that pollinates one species of orchid. They're highly specialized in terms of their vector. And mimicry is sort of the ultimate example of that, where the flower literally physically looks like the insect and it tricks the insect into thinking it's its own species. And we'll see some pictures of these. It's pretty amazing. And then the other thing about orchids is they often have obligate mycorrhizal relationships. In other words, they can't even live without the fungus being present. This is why our native orchids, for example, are so difficult to transplant. You might see the pink lady slipper in the woods and be really tempted to want to dig it up and, plant it. But honestly, they don't usually transplant because they have this fungal component that they need. And without fungal component, they don't survive. Sorry, I was just making sure I was recording after my fiasco with the computer dying. I want to make sure I'm getting my money's worth here. Okay. Now, to be clear, the more primitive ones may have mycorrhizal relationships, but they're not obligate. And what I mean by that is the plant can still live without the fungus. It just might do better with the fungus present. Okay. And so this gives you a pretty good idea of what's considered more primitive and more advanced. Now, with that said, does that automatically mean that the more advanced ones are better able to survive and the more primitive ones are not? No, it doesn't. In fact, if you think about it, what we're seeing now, out of all the plant families on Earth, guess which one is going extinct fastest? The orchid family. They're just simply too highly evolved. They're too advanced. You know, and so you think about a single vector pollinator, for example. If something happens to your pollinator, you can't complete your life cycle. Compare that to the wind, nothing's happened into the wind, or when you have 15 or 20 different kinds of insects that visit your flower. Think about obligate mycorrhizal relationships. Something disturbs this fungus, these mycorrhizae, and they die, then you die. And so what we see is just kind of the opposite. The more primitive plants in this day and age seem to be doing better than the orchids. We're losing orchids every day, especially in tropical rainforests. Let's look at some mimicry, just because it's pretty amazing to see, honestly. Um, and so, you know, it's sort of the ultimate pinnacle of evolution is this idea of mimicry. And you know, the idea is the orchid mimics the insect that pollinates it, usually the female of the species, because we know the males are dumb. So here's one that mimics a bumblebee, and there's just no, if you saw this species as pollinator, you would immediately recognize it as looking very much like this flower does, you know. And so it's literally attracting species to it in an effort to trick the male who thinks he's, you know, gonna get some, and instead he's just getting tricked. He's getting duped. In the process of trying to literally copulate with this flower, he accomplishes pollination. Here's one that mimics a fly. Okay, and I mean, as you scroll down, you can see many more examples. Here are the pollinators and the flowers, and you can see, you know, some similarities there. This one I love. This was really one of the most impressive ones to me, with the hairy abdomen of a mimicking a bumblebee. Okay, so the idea is, how does this happen? It happens through millions of years of random mutation. The more the orchid mutates to look like its pollinator, the more likely it is to get pollinated. It's that simple. Okay, so you know, fascinating examples. I don't think that I'm leaving any particular thing out. I think we're, gosh, y'all, I think that's the end of the line for us. And what I want to tell you about this last test is it just covers the gymnosperms and angiosperms and their life cycles. Anything that we talked about is fair game. Keep in mind, you know, there's not a huge amount of information, but this test is still worth 500 points. There's still 500 points out there. So really know the material front and back. It's been a pleasure, y'all. I hope you go on to continue studying botany, but if not, at least you can probably walk around outside and know a few plants, okay? And you certainly know something about their life cycle. All right. Adios. It's been a pleasure. Take care. Bye-bye.